Hello and welcome to another episode of Azure DIY Season 4. This episode is Cutting Edge Azure Sphere IoT Acceleration presented by Dave Glover. Rather than a partner, Dave is actually a Microsoft Cloud advocate. So he's one of the folks who is an expert in the field, goes and talks about what Microsoft is doing in cloud. And today he's probably one of the world experts on the Azure Sphere. So rather than ruin his thunder and talk about Azure Sphere, I'll let him talk about it directly. But I want to welcome you to yet another Azure DIY episode. This is our calendar for the remainder of the season, so we're working our way through. Next week, definitely come through for machine learning operations. It's going to be a really exciting session for anybody who's doing anything in ML, anybody who's doing DevOps around data. This is going to be a really fantastic series for you. And then in 2 weeks, we're going to have rapid development on the Power Apps platform. So for those of you who aren't professional developers, but are wanting to get into application development, the Power Apps platform might be the proper platform for you. If you haven't already, go and register immediately for any of these events that are coming up. If any of them are exciting to you, the link is at the top right-hand side of the screen. And again, certainly use that QR code if you prefer the QR code lifestyle. And again, if you are not already a part of our LinkedIn community, here is the link to the LinkedIn community. This is a way for you to find out about upcoming events, either from Azure DIY or anything that we're doing in the Azure DIY community. It's a great way for you to connect to other folks in the community, and certainly for you, those of you who want to reach out to those of us who are part of the Azure DIY team. A little bit of housekeeping. All of these sessions are recorded. We do post those on LinkedIn, and we do post them up to YouTube. So if you've missed some or all of it, or you just want to go back and revisit the session, the link will be there for you to go and check it out. If you want to have any questions answered, go ahead and ask them in the chat, and we'll make sure that they get off to Dave. Or if there's something that you're just asking generally, we're happy to answer them for you in the chat as well. Ask early, ask often. The Q&A sessions on these tend to get really robust, and so I'm really looking forward to your questions as you come through. We will have about 10 minutes at the end of the session for Q&A, and to answer the question that all gets asked pretty much early on, is there going to be demos? And the answer is yes, absolutely. This one is going to be especially rich with demos, so buckle up. Last but not least, a couple of really good announcements. As you probably know, Microsoft Build is happening right now, and there's been a lot of announcements that have come out of Microsoft Build. One of the big ones right now is we've taken a lot of the Azure Cognitive Services and we've started to combine them together into a heading that we call Azure AI. One of the really interesting ones that we've put out there is we've taken Azure Video Analyzer, and we've created the Azure Video Analyzer service, which is now in preview, but we've taken the live video analytics and the live video indexer, and we've smashed those together into a single coherent service. So if you're looking to get some insight from some pre-recorded video or for some live video, this would be the service for you to take advantage of it with. We've gone and we've taken some of the PaaS services that you probably know and love, things like Azure App Services, Logic Apps, a lot of the things that we talk about on the Azure DIY show, and we've now made them available for you to run on any Kubernetes cluster that you happen to have access to. As long as you're managing that Kubernetes cluster with Azure Arc, you can now run some of these first-party Azure PaaS services on top of that. So that's very exciting for those of you who are doing hybrid computing, those of you who are spending a lot of time in Kubernetes. Now you can go and deploy some of these higher order services. And last but not least, any of you who are in the IoT space, and especially if you're doing industrial IoT, now we have the ability for you to do IoT edge nesting. So if you have a requirement for critical assets that are under some sort of requirement for network isolation, so you're running an OT network and you want to be able to collate that data, collect the data, and then emit that data into the cloud in a secure way, we now have the ability for you to manage those IoT assets together. So without further ado, I'd like to introduce Dave Glover. As I said, he is a Microsoft Cloud advocate. He is a fantastic person to talk to. He's been around the industry for a very long time, both with Microsoft in general. He's a wonderful person to talk to when any sort of electrical engineering interest that you might have. He's a fantastic person to talk to. So encourage you to connect up with him on LinkedIn, or if you see him presenting at any of the many conferences that he attends and speaks at, I encourage you to go and check it out because it's guaranteed to be something exciting. So Dave, let me hand it over to you. Welcome to Azure DIY.
Awesome. Thank you very much, Gary, and thank you very much for talking me up. Hopefully we can live up to expectations. So as Gary mentioned, I've probably got too many slides and too many demos, so we'll see how we go with this talk. So my name is Dave Glover, and My role is of a cloud developer advocate, and I have a focus on the Internet of Things, and I'm based in Sydney, Australia. You can follow me on LinkedIn. So they're on Gloveboxes, linkedin.com/Gloveboxes, and you'll find there's a bit of a theme there. So on GitHub, I'm also Gloveboxes. Alrighty. Okay, so the first thing about this talk is it's actually going to follow, kind of mirror a MS Learn module that I've written that you can get to from that link there. So if you want to pop a screenshot of that, so aka.ms/learn/IoT Hub. If I've gone too fast in some areas, you can always delve into this Learn module and kind of get down and understand a lot more what's going on. So I thought I would actually start with like a very quick high level, what is an IoT solution? Sometimes I do these talks and then people say to me, what's an IoT solution? So the kind of things we talk about IoT, we've got things that generate data, we've got insights based on that data, typically lives in the cloud, and we've kind of got some actions, and actions we base on that insight. You might want to automate, I don't know, the energy inside or lighting system inside a building, an office, a factory, or things like that. This talk is really going to focus on the things, and then specifically, we're going to be talking about Azure Sphere. And we're talking about Azure Sphere and Azure Sphere with Azure RTOS, which is a real-time operating system that we can also run on partner cores on the Azure Sphere. Alrighty, so in terms of the why IoT, I guess the main thing about it is really being able to fuel digital transformations, that kind of complete loop of what's going on, how our customers are using our products, how our factories are performing, how our products are performing, all those types of things. And the various estimates of the number of connected devices by 2020, I think this was 20 billion. Again, those estimates change quite radically depending on who's saying them. But the interesting one I thought was by 2025, something in the order of 180 zettabytes of data being generated by IoT devices. Now, to be clear, when we talk about IoT devices in this category, that also includes mobile phones and things like that. So there's a lot of devices out there. The key thing about that, there are a lot of devices. Now, of course, digital transformation really has an amazing opportunity to change the way in which our businesses operate, our lives operate, governments, and all those types of things. But of course, there are some inherent dangers with IoT. Really, the number one, I would say number two and number three are actually around security. And that's something that's often overlooked when you're building solutions in a race to get a solution out to market. You want to get the product out there quickly, and often security is neglected. And this is a great example. You've possibly seen this around before, but this is a fish tank that was sitting in a US casino. And what happened is that this fish tank had an IoT device in it, and the device was monitoring the salinity of the water, the temperature, it was automatic feeding, all those types of things. Now, what happened was that hackers got into the sensor in this fish tank, and they were able to get through that sensor, then onto the corporate network, and then into the corporate databases, and then to be able to steal off something in the order of 10 gigabytes of data from the high roller database. Now, you could argue there were lots of things that were wrong with that solution. Putting an IoT device on the main corporate network in a public place was probably not a smart move either, but there's a whole range of things here that you need to be considering around security. And really what I'd also say is that when you kind of get into building IoT solutions, not only do you have to be a domain expert and I don't know, maybe a parking system or a lighting or factory system, but you would also invariably need to become a security aspect or security expert. So as we probably all know that security is complex, it's really complex to get right. And probably more importantly, it's evolving, it's ongoing. So you're never quite there, it's a journey. And as I just mentioned, when you go into the IoT world, you also need to be a security expert. And we're talking a bit about what we're doing to try and help alleviate some of those issues around security so you can focus really on your domain skills to bring an IoT solution to market. Okay, so Microsoft in the industry has really defined 7 properties that are required for highly secure devices. So things like a hardware root of trust, so which is really an unforgeable identity for a device. Compartments, so things like different software components are isolated from each other. Certificate-based authentication, super important. One of the biggest hacks that actually took down the DNS server in the east coast of the US was being able to use a standardized password to be able to hack into security cameras. So there was a standard number of, a whole lot of security cameras out there. They all had the same password and they all had, I think it was SSH or something like that enabled. And hackers were able to get into those devices and then start using them for purposes which they were not intended. So certificate-based and be able to cycle those certificates is super important for this. Things like error reporting. If you don't know what's going on, if someone's attacking, you don't know what's actually happening, then you don't know how to mitigate against it. Now, there's a link down at the bottom here, and again, I would encourage you to capture the screen, which is aka.ms/7properties. And that document there will go into the 7 properties for highly secure devices in way more detail than I've just covered. Now, Azure Sphere is made up of 3 components which implement these 7 properties. So the first thing we've got is an Azure Sphere certified microcontroller, and they're from a number of partners, and they come with a burnt-in hardware root of trust in those devices. And I'm going to talk about the partners that are supplying devices today. There is also the Azure Sphere OS. And interesting enough, it's a Linux-based hardened Linux kernel, which actually exposes up a POSIX API for building applications against. So the important thing about this is we manage that. As there are new vulnerabilities found in the kernel, we patch those, and those go out in regular updates. So again, that whole Azure Sphere operating system is part of our strategy to make sure that we can see that there are certain types of attacks that we're seeing across the board. We can ensure that the OS is actually patched against those. And again, I go back to the point before, is security is a journey. Unfortunately, we're in a situation, we've probably always been in a situation where security vulnerabilities evolve or attackers get smarter in ways in which they go and attack systems. And then on top of that, we've got the the Azure Sphere Security Service. And this is a cloud service, and it's responsible, there's a number of responsibilities in things like brokering trust between the devices and cloud services, detecting emerging threats, ensuring that the certificates are refreshed on a daily cycle, and things like application reporting. Has my application crashed? That's a super useful information. It might not have been to do with an attack. There might have just been an error in the code. And you'd be able to get access to all that kind of reporting data, which again can help you make a more robust product. Now, I want to talk a bit about the overall architecture of an Azure Sphere. So as I mentioned before, Azure Sphere is made up of 3 things. So we've got the MCU, the microcontroller unit, the bit of silicon. We've got the operating system, and we've got the cloud service. So this is very much talking about the microcontroller. So the important thing about this is it's what's called a multi-core microcontroller. And there are actually 3 cores where you can deploy your own custom applications. And those are highlighted in red. So on the left-hand side, we've got this core called the Cortex A7, which is also known as an application core. Now, on that core, we're running the Linux kernel. We're also running a number of system services. So, for example, update services, reporting services, certificate services, things like that, as well as your custom application. So that lives on that core. Now, there are also another 2 cores that you can go and deploy your applications on. And these are called Cortex M4s. And they're a very popular microcontroller. So we've got this Azure Sphere, which has got, as I said, multiple cores on there. And we've got these 2 cores, which are called real-time cores, that you can go and deploy real-time applications onto. Now, by a real-time application, I talk about applications which mostly are around requirements around highly deterministic timing is often the thing that you want for real time. So, for example, you might have an application which has a sensor which must be serviced. Its interrupt must be serviced within a certain amount of time. Those are the types of things. Now, that's not always the reason why you might use a real-time core. You might want to use it because it's another set of resources on this Azure Sphere. It's a controller, it's got memory resources associated with it, and it might be very useful for your application. So there are a couple of reasons why you might want to do that. The other cores in here, we've got a core which is called the Microsoft Pluton, that runs a security subsystem. There's another core out there which is responsible for connectivity. At the moment, we've kind of got Wi-Fi and Ethernet, and there's flash storage and RAM. And then below that, we have all the things like peripherals. So it's called what's called multiplexed I/O. So certain pins or peripherals can perform multiple functions. So as you'd expect, we've got GPIO, pulse width, I2S, I2C, SPI, analog to digital converters and things like that. So that's the architecture of the solution of the Azure Sphere. And I'm going to show you shortly in a demo kind of how that kind of all plays out. Now, in terms of how you can get and start building on an Azure Sphere. So the first thing, there are, as I mentioned, certified MCUs. Which are certified Azure Sphere MCUs, and they have the hardware root of trust, as well as the number of cores. There's a basic specification for an Azure Sphere. Next, we have what we call developer kits, and they are really around rapid prototyping. So you've got an idea, and whatever it might be, let's say it's managing the lighting system inside a factory or monitoring something or whatever it might be. And you want to be able to prototype it, and that's where these types of solutions come into place. So we've got a prototyping solution from Avnet that's called their starter kit, and there are two boards over here to the right-hand side. They're from Seed Studio. So the middle one here is called the reference design board. Excuse me, and that was the first board that was come out to market. And then they also bought out another board which is called the Mini. And the Mini is a cheaper price point, and typically what you do is you plug it into a Grove connector. Then in terms of when you've decided, look, I've got my solution, I've proved it out, and yep, I'm ready to go to market with this, then what you would typically do is you'd go to a manufacturer of modules. And organizations like Avnet and AI Link, you go to those people, they have certified those modules. You say, look, I want, I don't know, 500 of them or whatever. I'm going to take those modules and I'm going to put them onto my PCB that I've designed to support the solution. Then on top of that, though that's if you're doing your own solution, then the other types of ways in which you can kind of build with Azure Sphere is what we call Guardian modules. And I'll talk about slightly more about that in the next slide, actually. But there are a number of Guardian modules, and we talk about what we call brownfield. So you've got greenfield, and that's kind of like a new solution that you're coming out to marketplace. Then we have the idea of brownfield, and brownfield is typically about securely IoT enabling existing devices. Let's say you've got a factory device. It was really built before the internet protocols or secure protocols, and you want to be able to start monitoring that and having information delivered up into the cloud. Then what you might potentially do is look at one of these Guardian modules and say, look, that Guardian module has the interfaces that I require for my piece of equipment in the factory. I'm going to use that as to kind of basically proxy or work on behalf of this piece of machinery to send the data up securely up to IoT Hub in this case. So as I mentioned, we've got greenfield devices, which are typically a new solution, and we've got brownfield devices. And the one that, if you have a dig around the Azure Sphere site, Starbucks is a great example where they wanted to be able to internet enable their coffee machines. And there's a certain set of devices, interfaces on those machines. And what they did is they used a Guardian module to be able to connect to the interfaces on the coffee machine, and then to be able to send the data through up into the internet. And then they kind of started doing interesting things like building loyalty programs and interesting things like that, or just maintenance for the coffee machine. So again, greenfield, brownfield. And the reality is we probably think that the bigger opportunity out there is really going to be brownfield, people trying to internet enable existing equipment. Okay, so that's kind of a bit of the background on the Azure Sphere, the architecture, kind of what we're trying to address with it, and things like that. Okay, so the next thing, we're going to start off in a bit of demo land. And my first demo here is going to be around something called the Altair. Now, depending on your age or your interest in the computing and retro computing, I guess, there was a device which was really the Altair 8080, which came out in the late 70s and early 80s, which really kick-started the personal computer revolution. It had an Intel 8080 microprocessor in it, and the Intel 8080 was kind of one of the first general purpose microprocessors. Relatively simple. I think it had in the order of 78 instructions, and it came out in 1974. So what we did is we thought, excuse me, it would be interesting to take the software that was used to drive the Altair 8080 and migrate that onto an Azure Sphere. And what we did is we cloud enabled the Altair 8080 running on an Azure Sphere, and we kind of took advantage of all the capabilities of the Azure Sphere. And the next slide here, in fact, I got a little example here. Whoops. I thought this was meant to be a video. Sorry, I thought it was a video, but it's not. So this is an example here where we took the front panel, so you can see the front panel there of the Altair, and there was an open source hardware design for this. And we took that open source hardware design and we kind of added a little bit to it. And we have also published, or we're about to publish, this open source hardware design for the Altair front panel as well. And the way the Altair works, and you can see here it's hooked up to an Azure Sphere. In this case, it's the AVNet starter kit. And the way that the Altair worked is you basically set, you can see the switches along here. You could go and set the values of data, the data bus or the address bus. And then there were some control switches down here, and you can see, look, I'm going to run or stop. We had what was called single step, and you could do what's called an examine. So an examine would examine the contents of a memory address, and you could do examine next, and you could deposit a value into a memory location, and you could deposit next. That was the kind of idea behind it. So that's pretty much how the solution works. And this, I'm now going to describe to you what the components were for building this, running this Altair application on the Azure Sphere. So we've got three kind of major components. And by the way, this is all going to be open source, and we built this on open source. We did not go and rebuild and reinvent the Altair stack on this. There were open source components that we use to go and build this. And again, this whole solution will be open sourced under MIT, and you will be able to have fun building this as well on an Azure Sphere. So kind of give you a bit of the idea of the anatomy of the solution. We've obviously got the Azure Sphere OS, so this is on the Azure Sphere. On top of that, excuse me, we had two communications libraries. This solution made heavy use of something called MQTT. It's a very popular IoT communications protocol that you can securely transfer messages backwards and forwards to the cloud. And we also use the Azure IoT SDK. Then stacked on top of that, we had the concept of terminal I/O. So effectively what we're doing is we're redirecting standard in and standard out of an emulator. And what we're doing is we're hooking that and across this terminal I/O, and we're hooking that across MQTT and out across the internet. And we're doing the same with virtual disks. If I want to go and do a sector read, that gets hooked down into this virtual disk driver, and then it gets passed across the internet over MQTT. Then on top of this, we're running two binaries. Oh, sorry, I jumped a step. And then on top of those terminal I/O and virtual disk, we're running an Intel 8080 emulator. So yes, we're running an emulator, so a 1974 general purpose CPU running on an ARM chip. And again, that was all open source. Hope I don't lose my voice. So we've got an Intel 8080 emulator running on top of an ARM chip on the Azure Sphere. And then on top of that, we've got the binaries for Altair Basic which was really the Bill Gates, Paul Allen work that they did initially to work on the Altair, and which really later evolved into Microsoft. And we're also running another operating system on there called CPM, which I think was something like Control Program Monitor or something along those lines. It predates DOS. So again, it goes back to the late 70s and early 80s. It did fade away when DOS came along. And then on top of that, because we're developers, I have got on there a basic interpreter, C compiler, and an assembler. And on top of that, I've got custom applications. And then on the same core, I'm running 2 applications on the 2 real-time cores on the Azure Sphere. So I'm running a disk cache, which I'll talk about shortly in a bit more detail, and I'm running some sensors. So I'm really using all the cores on the solution. And then in the cloud, I'm running on Azure, and the cloud services there, I'm running a virtual machine where I'm running an MQTT broker. The broker is Mosquito, again, just an open source broker. I'm running a static web app, which is called, in this case here, it's called Altair Web Terminal. And I'm using IoT Central to go and do configuration reporting. And the next component, I've got a web-based terminal. And this web-based terminal talks MQTT. So it talks MQTT to the broker in the middle running in the cloud, and then it talks to MQTT running in the Azure Sphere. And that's a thing that's basically the traffic is flowing between the Azure Sphere and the Altair and this web terminal. And the web terminal, I'm using an open source project called Xterm, which provides amazing terminal experience. So that's how I kind of get into this. And then I'm going to talk about one more thing, and then I'm going to show you in action. Just to show you how I did the caching. So we've got the Azure Sphere, and the way this did is that we hook disk requests and we pass them across the internet. And then I've got a Python application, which is basically a disk server. It can serve disk sectors. I want disk 1, it'll return me back 137 bytes for that sector. Disk 2, sector 2, etc. Whatever that sector was, this application will return that. Now, as you can possibly imagine, doing each request for a disk access over the internet would probably be not that fast. And it wasn't. So the approach I took to that was using a disk cache, a look-aside cache server. And it's a least recently used cache. And the way this would work, as I'd say to the virtual disk server would say, okay, I'm after disk 1, I'm after sector 1. It would basically send a request over to that real-time core. The real-time core would say, I don't have that sector, and report that back to the virtual disk manager. The virtual disk manager would then go across the internet and say, hey, look, to the virtual disk server, I want disk sector 1. It'd say, yep, I've got that, return it back. The virtual disk manager say, here you go, Intel emulator, and would also write that to the cache on the Cortex M4. And obviously the next time the application says, hey, look, I want disk 1, sector 1, and the virtual disk says, it puts a message across to the Cortex and says, I want sector 1. That cache is going to say, yep, I've got that, and return it back. And that typically would take around about 200 microseconds. It's really quick. Now, the example here, I'm using the sectors, but obviously this is a bit of a made-up example. It's kind of a fun retro project, but you might want to use it for shopping. So let's say you've got a point of sale application, you want to do price lookup units, and you might have that those price lookup units being served from the cloud, but you also want to have that shopping solution, work offline as well. And this way you can also have a way in which you can have the pricing information for a good that might be one that someone wants to scan. That information can be readily available, and obviously you'd have a time aspect on there as well. So kind of an interesting pattern to be able to use different parts of the Azure Sphere to provide services to kind of augment the main application. All right. Excuse me. Right. So what I'm going to do is bring up the terminal, and I'll just double check for my own sanity that's going to work. And alrighty, here we go. Way, now it's decided it wants to reboot every moment. Okay, so what I've got here is I've got an Azure Sphere. Now this is not the same front panel that I showed you in the slides. This is more of an off-the-shelf solution. So we think some people will want to go and build their own front panel using that open source hardware design. But the general feeling is that probably a lot of people want to go buy off-the-shelf components. And what I've got here, this is on the Azure Sphere, the old AVNet board, is I've got two what are called click devices, and these are made by a company called Microelectronica based in Serbia. And what I've got on here is I've got the buttons, and those basically are the same principle here as the switches, and you can come along and press those. And for example, I can go and if I go and press that button there, it'll stop the CPU. If I go and press this button, it'll restart the CPU. So that's the general idea. Now I also have a console, which I'll explain to you, a low-level console. So if you ever had an experience with DOS, you would have seen DIR, or you still kind of we still use that today in Windows. And you can see I'm doing a directories. Now keep in mind what I've got here is that I've got a terminal which is talking MQTT to a data center that I've hosted up, a data center in Australia where I'm hosted up an MQTT broker. And on my desktop here, I've got the Azure Sphere. And I've got two drives. If I go to my B drive and I load that up, I've got various applications. And so, for example, in here, I've got demo.asm. And you can see I've got a bit of assembler. And if I come over to my A drive, I can go ASM, B, and I go demo. I just go demo. And that's assembled that code. I can do what's called a load. I go load, and we'll go load demo. And basically that'll kind of link it. And then I can come across to the application, and if I run demo, it says hello world. And if you look up here, in this bit of code, in fact, what I'll do is I'll load up something called WordMaster. WordMaster was a very popular text editor back in the 70s and 80s. And we'll load up demo.asm. And I'll just switch across into what's called character mode. And you can see down through here, if I jump around a little bit, and I'll go insert hello world from Azure Sphere. And excuse the typo in there, I won't fix that for now. We'll just escape out of that, go back to the A drive, go ASM, and it's B, and it's demo. And then I'll do linking of that B, and it's what I call it. It was called demo. And we'll go back to the B drive. And we'll go to demo, and it now says hello world from Azure Sphere with my capital P. So we've kind of got that in there. And again, what I'm going to do is just type demo.asm. And I can go what I call monitor mode. And what I'm going to do is you'll see that up here that this application gets loaded at 100 hex. And we'll go over here and we'll go 100 hex looks awfully like this. No, it doesn't. Like 100 hex. And what I'm going to do now, as you remember on the Azure Sphere, if I pop over here, I can in fact go and click this button here, which is an examine. And you can see what it's done is it's brought up the instruction, which is what's called a move immediate. And you look inside my assembler and surprise, surprise, you will see move immediate. The next thing I want to do is, in fact, there's a shorthand way I can actually do this in the terminal, which is called examine next. And you can see that the next instruction here, it said the first thing, this move immediate is a 2-byte instruction. So that means the second byte is going to be a value. And you can see up here, I'm going to print the string the print string function will be 09 hex, and you can see there goes the assembler. And the same deal, you can kind of go through here and work your way through that, and we'll pop back out of that. So anyway, that's kind of the idea behind that. And as I mentioned before, there's NBasic on there, and I can go and load up, and I can do go like print 2 plus 2, and hope for the answer's 4. So you kind of get the general idea. And as I mentioned before, there's a C compiler on there, all the general same kind of principle behind that. So that was the first demo, which is to kind of give you a bit of an idea of what the capabilities you're doing, or what you can do on an Azure Sphere. And as I said, what we've done is we've cloud enabled the solution. And we're taking a retro bit of open source code and put that on. And as I said, that will all be available. So if you do have a particular interest in retro computing and assembler and understanding how CPUs work, this is perfect, because the Intel 8080 had a limited number of instructions. I think it's 78, I said before. And it means you can start learning a bit more about how CPUs working. Obviously, not something you can do quite so easy today with the more advanced CPUs. All right. So the next thing I want to talk about is just what the overall developer experience is for Azure Sphere. Today you can go and build on Windows 10 and Ubuntu. The developer tools, you can use the free versions if you're building on Windows for Visual Studio 2019, Visual Studio Code and Command Line. And if you're building on Linux and Ubuntu, then you can go and use Visual Studio Code and Command Line. And all those are great experiences. You would use things like Command Line if you want to go and integrate the build process into your existing build chain. Integrated debugging, it's just superb. You can go and set breakpoints and step your way through the code. Alright, so the first thing I want to do is kind of give you a quick demo of what you can go and build on Azure Sphere. So we're going to do 3 things. We're going to send some data up to IoT Hub, which is always kind of useful. I'm going to do something called device twins. Now, device twins are a super handy way of being able to set up state on a device. So, for example, you might want to set the sample rate on a device. Hey, go and measure the light levels every 5 minutes. Go and mention the CO2 levels every 20 minutes, whatever you might want to do. So you can basically set state. You can also use device twins to represent a point in time. So the last time this device was started up was such and such UTC, Universal Time Coordinate time. And the idea over here, we're starting on the right-hand side. You would go and build an IoT Hub application. And inside that application, you say, look, I want to go and set the state, on a device. What happens is that message gets sent across, or that API call gets sent across to your IoT Hub. And there is a device twin for all devices inside your IoT Hub. And a device twin is basically a JSON document, which describes, it's just a cloud version or cloud reflected state of the device. So it's a JSON document. And then what happens is that IoT Hub will bundle that request up, send it across to a message, and a message across to the device. And the device will say, I've got a new device twin message, and it wants to set the temperature on the HVAC system that I'm monitoring. And then what it would do is report back saying, hey, look, this was successful, and the application can go query it. So that's kind of how it works. The other approach is kind of more of a request response kind of approach. You want to go and turn a fan on, for example, and you might go and invoke what's called a direct method. And that direct method you would have your application send a message to IoT Hub. And then IoT Hub would then bundle that direct message up as a message and send it down to the Azure Sphere. And then the Azure Sphere would say, there goes a direct method. I know about you. You want me to go and turn on the fan or turn on the light. And then I would respond back and say, yep, I was successful, or actually, no, I failed. And it's kind of, as I said, more like a request response. Think about it almost like an HTTP GET. You go and do an HTTP GET across the web, and the browser responds, or it fails, and you get 400 or 500 or 200 HTTP status code if it succeeded. The other thing I'm going to talk about is something called IoT Plug and Play, and you'll see this in action in a moment. So what we're trying to do is you think about, again, if you think about your desktop computer, it doesn't matter if it's Linux, Windows, or Mac. We're all pretty much used to the idea of printers. We're going to plug our printer in and the device drivers load up for that printer, and it's pretty much seamless nowadays. And what we're doing with IoT Plug and Play is really the same concept, is having a standardized schema to go and describe devices. And you can see the schema over here on the right-hand side. It's what's called a device twin definition language schema, and it goes and describes the capabilities of the device. So the elements it defines is the shape of the telemetry. It describes the properties and commands. Properties kind of map to device twins, commands map to direct methods. And the whole idea behind this, if you have a device which conforms to and has a plug and play specification defined for it, then it means that, and if you build a back-end application which understands plug and play, it means that you can pick up a device which is plug and play enabled, kind of drag and drop it into your solution, and your solution will go and configure itself and say, oh, yep, I understand that. It understands it exposes these properties, this telemetry, these commands. And the whole idea behind this is to reduce the manual amount of work that's required to go and build an IoT solution. So great examples of solutions today that use plug and play, and these are no means the only ones, but things like Azure IoT Central and Azure IoT Explorer. And there's a catalog of devices today which support IoT Plug and Play. And I'm going to show you this in the IoT Explorer shortly. Okay, so the next thing I'm going to do is I'm going to delve into building an Azure Sphere application. And we'll just quickly go through this. But the first thing about an Azure Sphere application is that they are secure by default. You remember how I mentioned that fishbowl example where hackers were able to get onto that sensor, and then once they're on that sensor, they were able to get access to all the resources that were sitting on that corporate network. Well, that is not the way the Azure Sphere works. So an Azure Sphere can only access the resources that are being defined and declared in what's called the app manifest. So you can see in down here that I've got capabilities here for GPIO. This application can only access these GPIO. I've got red, green, blue LEDs. I've got a network connected LED, and I've got ITC. Also, I've got down here that this application can only access these network endpoints. So let's say absolute worst case, that something got onto the Azure Sphere, it couldn't get past those applications. So let's say you made a mistake in your application. That application would fail as soon as it tried to access any endpoints outside the ones that have been declared. Alrighty, so what I'm going to do now is I'm just going to fire up Visual Studio. In fact, I've got it already fired up, and I've created an application. Now, this application is basically a slightly modified version of the learning path that you can go through on MS Learn. And basically what I've done is I've just cut out the guts of this, and I'm just going to go through and build this application as we talk. So the first thing I want to go and do is I want to declare something called timers. Now, timers are the recommended pattern for building applications on Azure Sphere. Typical pattern, hey, look, I want to go and measure a sensor every 2 minutes. I want to go and measure another sensor every 30 seconds. I want to go and report the data to IoT Hub once a minute. Those are typically the kind of patterns that you have. And what we have here is a way in which you can go and declare the timer. And you can see in here, I declared a timer called measure sensor timer, and it goes into this set. And if I scroll down through the C application, keep an eye on that timer set. If I scroll down to the kind of like the initialize down here, you'll see I've got a kind of a convenience function which knows how to go and open up all the timers that are declared in this timer set. And invariably you'll have a lot. I've only got one example. I've only got one time in this example. Okay, so the next thing I want to go and do once I've gone and declared my timers is you'll see in this timer there is a handler. So what's going to happen, this timer is going to fire every 4 seconds, and it's going to call this C function called measure sensor handler. And I'm just going to scroll, I'm just going to copy and paste a bit of code And the implementation for this is going to be down here. So what's going to be happening is that every time this timer fires, it's going to call this measure sensor handler. And there's a bit of, I'm going to build a JSON packet with SNPrint, and then I'm going to send that message to Azure. Now, the next thing I'm going to do is I'm going to declare some device twins. And we'll scroll down through here, which I'm going to copy and paste. And I'm just going to replace that. And I've declared a number of device twins. And I've got a desired temperature. So what's going to happen inside the IoT Hub, I'm going to set something, a JSON document, a JSON twin, which will be reflected down to the device. It's going to call something called device twin set temperature handler. And I'm also going to do some reported properties. And if I scroll down here, I'm just going to copy and paste another bit of code into the solution. And down through here, I basically put in the handler for the device twin, and I'm going to set a breakpoint. Okay, so first thing I'm going to do is I'm going to deploy this application to the Azure Sphere. And while that's starting up on the Azure Sphere, so the first thing it'll do, it'll kick out the application that's running on the Azure Sphere, which is obviously the Altair application at the moment. It's going to kick off that and then deploy the new application. And it'll connect and the debugger will eventually start. And I'm going to bring up something called IoT Explorer. So IoT Explorer is the useful tool for when you're building applications to be able to kind of understand what your solution, how your solution is talking. And inside IoT Explorer, there's the ability now to go and set what are called plug and play repositories. So you might have your own personal plug and play repository, or you might have gone and put the you might have put your plug and play a model on the web, which is what I've done. So I'm going to go across to my connections in IoT Hub, go across to here, and the device that I'm going to connect into is this one called 8293. That's the Azure Sphere that I've got sitting on my desktop. And you'll see down here that I've got IoT plug and play components. Now, if I pop across to the application, and I'll scroll back up to the top down, scroll around here somewhere. Yeah. You'll see, and you'll learn more about this when you do the learning module. But basically what I've done is I've declared a plug and play model ID. And you can see in here, it's called dtmi.com examples Azure Sphere lab monitor. And that's sitting up in the public repositories of plug and play models. So I've got down here what's called the default component, and there goes the model description. And if I go to telemetry, if I go click on start, what this will do is that this will now start listing out for the telemetry that's been sent from the device. And if you've done this before, you might be thinking, well, that's not very interesting. I can do that already. But what I'm going to do now is I'm going to click on show modeled events. Now, what this is doing, it's taking the plug and play model. So remember, the plug and play model described the data that's been sent from the device. And you can now see I've got a richer view of this data coming through. It tells me that the schema for this is float, the unit is Celsius, the value is 33, and it's temperature. And that's the kind of thing you can do with it. That's a value of plug and play, is it describes a sensor, it describes what's going on. So for example, I can come over here to properties. And what I'm going to do is I'm going to set a breakpoint in my device twin. In fact, the breakpoint's already set there. And I'll bring up plug and play, and I'm going to say, look, I desire the temperature on the factory to be 10 degrees Celsius for some strange reason. So I've sent that across, and now let's hit the breakpoint on the Azure Sphere. And if I bring this camera up, you can see that that's currently red. If I go, that little LED there with my fingers pointing is red, and I'll go and click on that. And through the magic of technology, you will now see it's blue. And as you go through the lab, you'll kind of get the idea, okay, what I'm saying, because I don't have a real HVAC system, I'm saying I can set the device to be 10 degrees, the current ambient temperature is 30 degrees. it means I need to cool the place down. If I set that to 40 degrees, update that, you'll see it will magically, when I get past the breakpoint, go back to being red. So the place seems to be heated up. So that's what you can do. That's what the device twins are working, and you can see that I've got the plug and play models being used. Okay, so that's pretty much the demos I wanted to show. There was one other demo which I've kind of run out of time for, but you can go to the learning module and understand more about that yourself. There's a great learning module there, and you get very straightforward. I'll just bring up the very simple demo just so you can kind of get the gist of what's going on. Whoops. I've got two applications that I can connect to the Azure Sphere. I've got this one here, and you'll see this when you go and fire this up. Red is for real time because that was fast and seemed like a good color to choose. So what this application here on the right hand side will be the application which runs on the real-time core, and the application on the left hand side is the cloud blue application which is running on the high-level core. And what happens is that these two applications can talk backwards and forwards to each other. So that's kind of how that works. Alrighty, so just to kind of wrap up, we'll go.
Dave, we have enough time if you're feeling frisky. If you want to go ahead and do that last demo.
Okay. Alrighty. In which case, what I would do is I will deploy the high-level application to the Azure Sphere. So you'll see down the bottom right-hand corner, it's deleted and it's deploying the application. Jump to a window. So that's kicked out my Visual Studio application. So that's now starting the application. So I'm using Visual Studio Code at this time. The reason I'm using Visual Studio Code is I can colorize the IDE, which is quite handy for this, but you can equally do this on Visual Studio 2019. So the application started up. So what I'm going to do now is I'm going to deploy the application to the real-time application. And you can look over the right-hand side, you can see the real-time application is now being deployed. And what I'm going to do is, hopefully that's okay. Yep, ignore the error. Okay, so that application, so I've got both cores running on the Azure Sphere. Both applications running on two cores. So what I'm going to do is, you remember in my first demo, I had this thing called Measure Sensor Handler, and it was using a high-level access to the sensors. In here, you'll see when you do the lab, or if you do the lab, you'll see that I've got a site change of API. What I'm going to do is I'm going to send a message across to the core, and the message is going to be, I'll just make this bigger. I'm going to send a command across to that core, which is going to say, look, I want the sensor data. So we'll just move that over here. And what I'm going to do is I'm going to put a breakpoint in my real-time application, pop back across to my high-level application, run that so it gets past the breakpoint. You'll see it's now hit the breakpoint in the real-time application. The real-time application is going to return back the current most recently recorded temperature, and through this application here, I'm going to call what will be called is what happens is when the message comes back, there's what's called an intercore handler. That's been wired up separately. I'm not going to go into how that's been wired up in this demo. And then what I'm going to do on the right hand side, I'm going to step out of that. I'm going to restart the application which is running on the real-time core. That will send a message across to the high-level application. And of course, like all good demos, for some, oh, okay, that's because it's hitting a breakpoint. And we'll just step through this. Okay, so there was a bit of slight confusion there. What happened because there was a bit of toing and froing going on and breakpoints being hit. But what's happened now is you can see that the intercore handler has been called. So a message has been sent from the real-time application across to the high-level application. The high-level applications got a handler which said, oh, okay, that's great. I've just been called. I've been called from the real-time core, and this is the application. This is the data. And that's pretty much how the application runs. And we'll just disable some of the stuff at these breakpoints. and the application will now continue to run. And you can see what's happening is that the data, is being, the request is going across the real-time core. Hey, real-time core, go measure that data, report back that data to the high-level application, and then I'm going to proxy that data up to IoT core, so up to IoT Hub. And if I go and look in my properties, look for my telemetry over here, start that, show modeled events, that will bring across all the data for me. Eventually. Rightio. Okay, so I hope that kind of gave you a bit of an idea how this is all hanging together. So in terms of the resources for this session, highly thoroughly, in fact, really kind of you have to do this if you're going to start building Azure Sphere. Do check out the samples. They are kind of the source of truth for Azure Sphere applications. We've also recently added in something called Azure Sphere Gallery, and these are what we're publishing what we find are interesting kind of patterns that we think a lot of IoT solutions built on Azure Sphere will utilize. I've already mentioned the Azure Sphere and IoT Hub in this Learn modules. Just go search for that. That'll bring that up. And there's also another learning module there for IoT Central. And if you don't want to do a quick screen scrape of that, that's where the IoT Central module is. And as mentioned, if you want to do a quick screen capture of this you can get hold of. These are the resources to go find more information. And that is pretty much the information. That was pretty much the session. So hopefully that kind of gave you a bit of an idea what is unique about Azure Sphere. The whole premise is that you remember that if you're building an application, you don't have to be a domain expert and as well as security expert. With Azure Sphere, what we're doing is we're kind of managing that security aspect for you. So you get to focus much more on your solution and the value that you're bringing to your customers. Remember, Azure Sphere is locked down by default. So all devices, all applications locked down, they can only access resources that have been identified. Super important. You don't want an application to be running rogue and suddenly being able to access corporate databases or camera systems or things like that. So those are kind of cool things about it. Remember, it's multi-core. The LTIP code project will be open sourced. Check out my GitHub, github.com/globboxes. There'll be a link to it up there. And yeah, thank you so much. And if there are any questions, now is the time to ask. Thank you.
Yeah, Dave, really fantastic. And thank you for sticking in there and doing that last demo. I was really keen to see you bring that through. So I appreciate it. A couple of questions that came up in the chat, and I know we're right there on time, but I want to get these out because it's clear that there were some interesting questions. Can you compare and contrast the experience of working with like an Avnet or a seed-based Azure Sphere dev board versus using something like a Raspberry Pi?
Oh, okay. So Raspberry Pi doesn't really have any security built into it. Okay, maybe that's a very general, broad statement because obviously you can start locking it down. But going back to this point before, the Raspberry Pi is a general purpose Linux-based system, typically Linux-based system. You are responsible for that device. You're responsible for patching it. You're responsible for making the security, making sure the solution is secure. When you build on Azure Sphere, we are managing the security for you. So we have a whole group of people who are looking and understanding what security vulnerabilities and how to mitigate them. We are doing that for you on your behalf. So that's the biggest thing. Raspberry Pi, you own everything. You own the security. You are responsible for everything. On the Azure Sphere, you say, Microsoft, I'm going to rely on you and all the expertise and the security people that you have, all the things around certificates, all the things around authentication. I'm going to rely on Microsoft and all the expertise to deliver that experience to the Azure Sphere. So that to me is one of the biggest fundamental things, the biggest differences about what you're trying to achieve.
Fantastic. That's all the time we have for today. Again, Dave, thank you very much for being our special guest on this particular Azure DIY session. And again, thank you very much for your attendance, both in person and those of you who are going to watch this streamed live over YouTube. Again, really fantastic program, Dave. Thank you very much. If you're not already part of our growing LinkedIn community, now's the time to go ahead and join. This is going to give you the opportunity to connect with folks like Dave, for example, and some of our other amazing partners who've been presenting this season, but it's also a way for you to be aware of what's coming up next. Last but not least, feedback is a gift. We really appreciate any feedback that you'd like to provide either on this session or what you'd like to see as another episode of Azure DIY. So connect in, give us your feedback right now. We appreciate anything and everything that you share with us. Thank you very much for your attendance. I hope you have a great rest of the afternoon. This has been Azure DIY.
Thank you very much.